So we have seen about the nomenclature part in the last class. Now we'll be discussing about the isomerism part in today's class, right? So what is this isomerism and all that we are going to discuss, right? See, basically there are two types of isomerism is there, right? And what is the meaning of this isomerism? Iso means what? Same. So there must be something same. What is that same? Same means what? Let's suppose if I am saying two people are looking similar, right? It means what? They are same. So in isomerisms, iso means same, right? So their molecular formula will be same, but the structure will be different. In isomerism, what we will be going to see. So let's suppose we are having butane, right? What is this? Butane is there. I hope everyone is familiar with this butane because we have seen in the last class only. Now the molecular formula will be what? C. How many C is there? 4. So C4. And how many hydrogens are there? So 3 plus 2, 5 plus 2, 7 plus 3, 10. So C4H10. This is the molecular formula for this butane. Is it okay? Fine. Now, if I have to do what? If I will take this carbon at this position, right? So what will be happening there? Count the number of carbon and count the number of hydrogen. Is there any change in the molecular formula? What do you think? So 1, 2, 3, 4. 4 carbon is there, so C4. Number of hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9 and again 10. So C4H10. So has their formula changed? No. So only what has been changed? The place of carbon has been changed, right? So these things we are learning in the structural isomerism, right? So iso means what? Similar and merism, right? So we are going to learn about what? This structural isomerism first. And in that structural isomerism, there are how many types of isomerisms are there? Chain isomerism, position isomerism, functional isomerism, metamerism, and tautomerism, right? And in stereoisomerism, we will be going to look about what? Geometrical isomerism and optical isomerism. Is it okay? So these five isomerism in structural isomerism, first of all, we will be looking into this. Then we will be going for the stereoisomerism. Is it okay, everyone? Okay. So now see about the chain isomerism. Although what I have discussed just now, that is a part of structural isomerism only that I have just discussed, right? So if you want to write the definition, then you can see from here. See, what is this structural isomerism? The compound have the same molecular formula, but different structures, that is different arrangement of atoms or groups of atoms within the molecules are called structural isomerism. Yes, that just I have discussed this only. And the phenomenon is called as structural isomerism. So what is this stereoisomerism? The isomer which have the same structural formula, but have different relative arrangement of atoms or groups of the atoms in the space are called stereoisomerism. So this part we will be seeing later on, right? And the phenomenon is known as stereoisomerism. So this is the basic definition. If you want to write, then please have a note of this. Now, in stereoisomerism, we will be looking into three types of isomerism. First one is what? Geometrical, optical, and conformational isomerism. So geometrical, optical, and conformational isomerism, we will be looking into what? That stereoisomerism. In structural isomerism, we will be looking 5 isomerism. That is what? That is chain isomerism, position isomerism, functional group isomerism, then tautomerism, and one is what? That is metamerism. That 5 will be looking into the structural, and these 3 in the stereoisomerism. Is it okay? No. Now we are going to see about the structural isomerism first. What is this structural isomerism? See here. Although we have discussed just now the structural isomerism, you can see from here. See here. Actually, if you want to draw, just now I have drawn the structures for butane, right? But let's suppose if I am taking the example for ethane or propane, if I will be transferring this carbon to this position or this position, the molecular formula and the structures remain same. In case of ethane, let's suppose if I am taking ethane, so we cannot draw the structural isomerism for this ethane, right? Even for propane, if you will be going to look, there is not possible. See, propane, what you will be going to do? You will be going to do this. Then also it will be coming into what? A same structure line. This is what? There is no isomerism for this 2 carbon, 1 carbon and 3 carbon. At least there is a need of 4 carbon to have a isomerism of that, right? So here you can see here that ethane will not show the structural isomerism, propane will not show the structural isomerism. So what will show the structural isomerism? That is what? That is what butane will be showing the structural isomerism, right? Now, see in this case, what has happened? Butane, 1, 2, 3, 4 carbon is there, right? So if 4 carbon is there, that's just now I have explained this only. I will be taking this carbon to this position, right? So there will be a structural isomerism for this butane, right? Again, if I am having the 5 carbon, then also it is possible to draw the isomer for that, right? What I can do for this 5 carbon, 4 carbon will be in the chain, and 1 carbon if I will be taking here, then that will be what? The isomer. And one other isomer that I can draw for this is what? If I will be drawing this carbon like this. So if you will be going to check the number of carbon and number of hydrogen, they will be remain same. So you can see here, butane will be showing the structural isomerism, pentane will be showing the structural isomerism, and in pentane you can see that there are two kinds of isomerism, two types of isomerism that we can see here. Once I have done what? I have taken the CS3 here, and in the next one I have taken what? That CS3 at the second position I have taken 2 CS3. This will be what? 2, 2 dimethyl propane. This will be what? 2, from pentane I have drawn what? From pentane I have drawn what? 2 methyl pentane also, 2, 2 dimethyl pentane as well. 2, 2 dimethyl pentane as well, right? So these are what? Structural isomerism. Is it okay? Now, some more examples I'm going to see. So if you want some more examples, you can draw what? You can take more carbon atoms. See, 5 carbon, then 6 carbon. And do what? Take this carbon to the second position, then take this carbon to the third position. You can change the number of carbon position and you can make the several isomerism of the same chain. Is it okay? So it's a lollipop type of question is there in the structural isomerism. It is very easy one. Now we are going to look about what position isomerism. What is the meaning of this position isomerism? First of all, try to understand from here what is this position isomerism. If position of functional group, same functional group is changed, it means, let's suppose if I am having a carbon of 3 carbon chain or 4 carbon chain, let's suppose, right? And here there is Cl is there, right? Now I am doing what? I am changing the position of the Cl or substituent or double bond or anything to other carbon. Let's suppose it is at second number, right? Now I am taking this at this number. The position of the functional group is changing, right? So this will be what? Your position isomerism. I'm bringing some more examples. See here. CH3, CH2, CH2, OH is there. This is what? Propanol, or you can say propan-1-ol, right? If I will be changing the position of this OH, that is what? Alcohol, I am bringing this to second carbon. This is at what? Second carbon. So the molecular formula remains same, but the position of what? Same functional group. There is no two different functional groups are there. If two different functional group will be there, then it will be what? That will be the case of what? Functional group isomerism, right? This is what? Positional isomerism. We have changed the position of OH from first position to the second position. Is it okay? What is this position isomerism? Is it easy, guys? Any doubt till here? No? No. The third one is what? The functional group isomerism. Now we are going to look about what? Functional group isomerism. So what is this functional group isomerism? See, what is this functional group isomerism? What is here? CH3, CH2, OH is there, right? This is one functional group. That is what? Alcohol. But if you will be going to see the number of carbon, that is what? 2 carbon is there, so C2. Number of hydrogen, that is what? 6. C2H6 is there. And O is there, right? This is the number of carbon, hydrogen, and oxygen. Again, I am drawing what? This CH3 is there. And O. And again C. You will be seeing that this is what? C2H6 and O is there, right? So the molecular formula remains same here. In this case also the molecular formula is same. But this is what you can, I hope this, I have discussed these things. This is what? This is what? Ether group. This is methoxymethane. Methoxymethane. Right? But this is what? Ethanol. Is it okay? The functional group is what? O. Like COC is there. Or ROR is there. Is it okay, guys? Everyone? Functional group isomerism, is it okay with everyone? Any doubt till here? No. I am taking one another example of this functional group isomerism. Aldehyde and ketone. I hope you all are aware about this aldehyde and ketone. There is a slight difference between the aldehyde and ketone. There is a difference of only H in the aldehyde and ketone. See, what is the basic difference between the aldehyde and ketone? First of all, try to understand that. The basic formula for this aldehyde is what? C double bond O single bond H is there. And this can be, it can be start from the first carbon only. The name of this carbon, the name of this structure will be what? Methanol. Right? But ketone is what? There is a difference of what? H. Here H is there, but in this carbon, there is no H is there. So this is ketone, and that is what? Aldehyde. So there is a difference of only what? H is there in the case of aldehyde and ketone. Ketone will be not having the one H, and aldehyde will be having the H. And aldehyde can be started from first carbon, but ketone we have to take at least 3 carbon. So it will be coming in this position. If let's suppose if I will be joining this double bond here, so there will be a requirement of 1 hydrogen. So it will be again that propanol. So we don't have to make propanol, we have to make what? Propanone. Propanone, right? And if you will be asking about 2 carbon, let's suppose we are having 2 carbon and there is a functional group C double bond O, right? And this is what? Ketone right now. But the valency of this carbon is not fulfilled. So we have to attach what? Hydrogen. If I'm attaching this hydrogen, then it will be what? Not ketone, it will be aldehyde. So this is not possible with first carbon and second carbon. It is possible only from the third carbon, 3 carbon. Is it okay? Now, look at about the functional group isomerism example. That is what? We are having aldehyde and ketone. Or we can see that aldehyde and ketone. Here H will be not there. O will be there, right? So what is the difference here? You can see here CH3, CH2, CHO is there. That is what aldehyde. This is what C, 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 and double bond O and H is there. This is aldehyde group. Now, if C, C, C and double bond O is here, and here you can see that what? Hydrogen. Count the number of carbon, hydrogen and oxygen. You will be getting the same number of carbon and hydrogen and oxygen. But the functional group you can see here, there is what? There is here is aldehyde and here is what? Ketone. Got my point, everyone? So there is a difference of what? The functional group, that is known as what? Functional group isomerism. Another example of this is what? This is what? Propene. Let's suppose here we are having what? CH2 double bond is there, right? I am taking this in the next page. That is what? Let's suppose this is there. Double bond attached here, right? So count the number of hydrogen first. Carbon 3, hydrogen 1, 2, 3, 4, 5, 6, C3H6, right? Now, if let's suppose if I am changing the position of this double bond and I am taking this as what? I am taking this as what? This. Now count the number of carbon and hydrogen first. 1, 2, 3. Here there is no hydrogen is there, right? Because 4 bond is there. Here there is 1 bond, right? So we can change what? We can change only the double bond position only, right? If double bond position is changed, so here is what? 3, 2 plus 1, 3, 3 plus 3, 6 is there. Here also you will be checking, seeing what? There is 6 hydrogen is there. Is it okay, everyone? So we have seen about what? This functional group isomerism. Is there any problem? No problem? Okay. Now we are going to see about what? Carboxylic acid and ester, how they are functional group isomerism. See here. How they are functional group isomerism, check from here. See. This is what? Ketone. And this whole part will be called as what? Carboxylic acid. The simple formula for carboxylic acid is what? C double bond O single bond OH. Right? And ester is what? That is RCOOR. Is it okay? So see here. But the molecular formula remains same. The functional group is changing. Here is this is what? Carboxylic acid. Here this is what? Ester. So the two different functional groups are there, but the formula remains same. That is known as molecular formula remains same. That is known as what? Functional group isomerism. Is it okay with everyone? Any doubt till here? Now we are going to look about the metamerism. The 5 types of isomerism in structural isomerism. We have seen 3 types of isomerism. First one was what? Chain isomerism or structural isomerism. And second is what? That is position isomerism. Third is what? That functional isomerism. And the fourth one is what? That is metamerism. We are going to look about the metamerism. So for metamerism, we have to understand first the ether part, right? What is this ether? See, what is this ether? First of all, try to understand the ether. COC. This is what? Ether. Or we are saying what? ROR. This is what? Ether. Right? See guys, there will be a change in position of metamerism. See what happens in metamerism. If let's suppose we are having what? C, C and O, and here is what? C. Now this time I am doing what? I am changing the position of this O to this position. Now it is what? C, O, C, C. So what will be happening here? The position of this O has been changed. Molecular formula remains same, but the number of carbon atoms after this oxygen has been changed. Getting my point, everyone? So let's suppose if in that place O or S or NH or CO is coming, and the number of carbon atom is changing, then it will be called as what? Metamerism. Let's suppose we are having one example. What we are having? CH3, CH2, O, then CH2, then CH3. We can write like this: carbon, carbon, oxygen, like this, right? So this is one structure. If I have to change, so what I can do? Right? This is what? Ethoxyethane. This is what? Methoxy. Methoxyethane. See here, the number of carbon is what? 4. So I can draw what? One more carbon. So it is what? Methoxypropane. If you are having any doubt in the nomenclature part, then please ask me. How I have written this? See guys, lower the carbon with the oxygen, lower the carbon with the oxygen will be act as an oxy group, right? You can see here. Here there is equal number of carbons are there, right? Either in the left side, either in the right side. So I have just written that 2 carbon is there. So for 2 carbon, we are writing what? Eth. And for this, oxy will be there. Ethoxy, ethane will be there. Here, we have to check first whether which side is having the lower number of carbon. So we have checked that there is in the left side, there is 1 carbon is there. And the right hand side of this oxygen, there is 3 carbon is there. So oxy group will be what? The lower number of the carbon will be representing the oxy group, right? So here what we can write? For 1 carbon, we will be writing methoxy. And for this 3 carbon, we will be writing what? Propane. Is it okay? I am giving you one more example and I tell me that what will be the name for that, right? Here is 2 carbon and there is what? Oxygen, oxygen, and this 4 carbons are there, right? So who will be telling me the name of this group? What will be the name for this formula? Who will be telling me? Kanishka, Pranav, DRC, please try to ethoxybutane. Very good answer. Is it okay? So the lower part will be oxy. Lower number of carbon will be represented the oxy group, and rest will be what? That is butane. So it is what? Ethoxybutane. Yes. I was teaching to one student and there was a confusion in the student. What is that? I'm giving you one question and I will try to find that whether the confusion is with you or not. Now tell me the name of this compound, guys. What will be the name of this compound then? Again, ethoxybutane. This is correct one, right? So the student thought what? Sir, the carbon that is coming in the left hand side will be only the oxy part, right? And the carbon that is coming in the right part that will be only the alkane group, right? But the thing is not that. What is the things? You have to check the lower number of carbon is at which side, that will be representing the oxy group. Whether it will be in the right or whether it will be in the left, that we don't have to take care of that, right? We have to take care of that. What we have to take care? We have to see that the lower number of carbon atoms. If the lower number of carbon is in the right, we have to take that as an oxy group. Or if it is in the left, that also we can take as a oxy group, right? And rest of the carbon will be representing what? That the alkane. Is it okay? So it is what? Ethoxy butane only. Is it okay? Fine. So we have seen four types of what? The structural isomerism. That is what? Till metamerism we have seen. Is it okay with everyone? Any doubt till here? Now, next one is what? Tautomerism. Next one is what? Tautomerism. Just a minute. See guys, what is this tautomerism? This is a special type of functional isomerism in which the isomer differ in the arrangement of atom, but they exist in dynamic equilibrium. Getting my point? Dynamic equilibrium means what? We have seen the case in case of the chemical equilibrium, right? So, but they exist in dynamic equilibrium with each other, and this phenomenon is termed as what? Tautomerism. Let's suppose we are having what? Acetaldehyde and vinyl alcohol are as tautomerism, right? See here. This is what? C double bond O single bond H is there. This is what? Aldehyde. Is it okay? Now see here. We are having what this time? The C, OH and H is there. This is what? Alcohol is there and double bond with the alcohol. This is what? Vinyl alcohol. Is it okay? So what is saying here? This is a special type of functional isomerism in which the isomer differ in the arrangement of atoms, but they exist in the dynamic equilibrium with each other, and this phenomenon is termed as what? Tautomerism. So acetaldehyde and vinyl alcohol are tautomers with each other. Here you can see what? Cyclohexanone is there, right? But here is what? Cyclohex one in one all is there. So they will be representing what? Here there is what? O is there, here there is what? OH is there. So they are in dynamic equilibrium and they are what? They are tautomerism. Is it okay? Here there is no double bond, right? Between the carbon. But here there is double bond between the carbon. Here there is no double bond in between the cyclohexane, right? But here there is double bond and OH is there. So these are the basic differences that we are having, right? I'm bringing some more examples for this. See this. We have just seen cyclohexanone and cyclohexene, cyclohex 1 in 1 ol. And the next example is what we are having. See, double bond with O, double bond with O, right? So this is what? Keto form. And here there is what? Double bond with this carbon, main carbon chain, right? So this is what? Enol form. So keto enol form is example of what? Tautomers. Is it okay? Keto enol form is an example of tautomerism. So these are these are 5 isomers that we have discussed about what? That structural isomerism, right? Now we have to see about what? The the stereoisomerism. So first of all, I have told you about what is the stereoisomerism, and in between that, what will be that stereoisomerism that we will be going to discuss here. See here. See here. One is what you can see here. In the stereoisomerism, you can see here what? One is what? That is cis, and another is what? Trans. Here there you can see there CH3 group is there, right? And here is what? H is there. And here CH3 is there. And again here H is what? If two same groups are at the adjacent side, if two groups are at adjacent side, then it will be what? Cis form. And if two groups are at different side, then it will be what? Trans group. Let's suppose here there is CH3 and one CH3 is here, and here there is H and here there is H. So this will be what? Trans form. Is it okay? What is this cis and what is this trans? Everyone clear with this? So if there will be cis, see here, cis form will be there. So more steric hindrance will be there. More steric hindrance means what? This is bulky group, right? This is what? Bulky group. If more bulky group will be at the adjacent side, so it will be creating more steric hindrance. Is it okay? Here there will be no steric hindrance will be there because the CH3 group, that is bulky group, are at opposite side. So one isomerism that we have discussed from this stereoisomerism is what? That is cis and trans isomerism. Is that okay with everyone? Any doubt till here? Guys, and rest of the isomerism of the geometrical isomerism and the optical isomerism that we will be seeing in the next class. That is, that will be discussed in the 12th standard only. Is it okay with everyone? Now we are coming to the next part, that is what, a kind of reaction mechanism part that we are going to see. So what is the meaning of this reaction mechanism that we are going to see? That is what? First of all, we will be looking about what? The bond fission. What is the meaning of this bond fission? Means that we have to break the bond. And until unless there will be no bond breaking, there will be no new compound will be formed in the organic chemistry. So first of all, we have to break, then there will be a new compound will be formed, right? Until unless if there will be no breakup, so how the new relationship will be built? There must be some breakup, then only there will be new relationship will be built, right? So types of bond fission, what are the types of bond fission is there? So there are two types of bond fission are there. One is what? Homolytic fission, another is what? Heterolytic fission. Homo means what? Same, and hetero means what? Different, right? So homolytic fission is what? Let's suppose we are having what? Cl and Cl, right? So they are formed a covalent bond between this Cl and Cl is there because what? 7 is in outermost electron, right? 7 outermost electron with this Cl, right? So this one electron will be shared with this chlorine, and this chlorine will be also sharing one electron to this chlorine, right? So there will be a formation of one bond will be there, right? And we well know that the electronegativity of this chlorine is what? 3. And the electronegativity of this chlorine is also 3. Electronegativity represents the bond strength, you can say that how strongly they are having and how strongly they can form the bond, right? So if and you can say the strongness of that atom, you can also say, or even you can say that element as well, right? So Cl, F is having the most electronegativity, that is what? 4, right? After this, we are having chlorine is also having a good electronegativity of 3, right? So they are having the same electronegativity. So they will be having the same power. Same power means they will be same strong, right? Let's suppose if there will be in any case they have to break the bond, right? Let's suppose they are fighting with each other and they have to break the bond. So what will happen in this case? See, 2 electrons are shared in between them. So chlorine will take 1 electron and this chlorine will also take 1 electron and they will be separated. Is it okay? So what will be happening in this case? 1 electron of this chlorine and 1 electron of this chlorine. Now there is no bond between this chlorine is there. If no bond between this chlorine is there, so this will be called as what? Free radical. This will be called as what? Free radical. So what happens? Once there is a breakup is there, so both are free. They are roaming in and around, right? So there will be a case with chlorine as well. So there will be a breakup of this chlorine, and they will be roaming around like free radical. Is it okay, everyone? No problem with this free radical? Now we are going to see about the heterolytic fission. What is the meaning of this heterolytic fission? We will be looking about this heterolytic fission first. See, homolytic fission we have seen. Now we are going to see about the heterolytic. See, let's suppose this carbon, and here there is what? Chlorine is there, right? We are knowing that chlorine is more electronegative, or I am taking carbon and X. X is what? That halogen group, right? Halogen group. So we are knowing that the X is always having the more electronegative than the carbon, right? So if this is having more electronegative, and if there will be a what fighting between this X and the C, so what will happen then? Although they are sharing the number of they are sharing equal electrons, right? They are sharing equal electrons. But if there will be fighting between these two, then what will happen? This X will be doing what? X will be taking its own electron as well, and it will be taking 1 electron from this carbon as well. Getting my point? What happens when you might have seen a case like, let's suppose we are going to play, right? In our childhood, we are going to play, and if there is fighting occurs in between the game, right? So what happens? The stronger the boy, stronger the girl, they are doing what? They are taking the play items and they go to their home. This happens. I know that this happens with in childhood, right? I was also doing the same. When I was going to play for cricket, what happens let's suppose if anyone is not following the rules, what I was doing, I was taking the wickets and I was going to the home, right? Now play, I'm going back. So this happens with this organic molecule as well. What will happen? This halogen will do what? Halogen will take this 1 electron of its own as well and 1 electron from this carbon. Now the carbon will become what? Electron deficient molecule. Yes or no? So if the carbon will become electron deficient, but this halogen will become what? There will be extra electron will be coming to this halogen, right? So it will become what? Minus charge. The element having the more electron will be having what? Minus charge over the head. Yes or no? So carbon will be having positive charge and chlorine will be having what? Negative charge. Yes or no, guys? What do you think? If both the shared electrons will be with this halogen, then the minus charge will be with halogen and plus charge will be with carbon. Yes or no? So this is the case when this X is having more electronegativity than, right? But think about that. In any case, if carbon is more electronegative than any other atom, not about the halogen I'm saying, right? Any other atom. Let's suppose that that atom is what? Z. Let's suppose I'm taking this C and Z, and there is a covalent bond between this C and Z, right? Now, this time I'm saying that carbon is having more electronegativity than this Z. Then at this time, what will be happening? Carbon will be taking both the electrons? Yes or no? If carbon will be taking both the electrons, then what will happen? There will be a minus charge will be developed over the carbon, and Z will be having the positive charge. Yes or no, guys? Please tell me these things. The three things that I have told you just now is what? One that I have told you about the free radical. Is it okay with you? The second one that I have told you what? If X is having more electronegativity than carbon, so here carbon will be having the positive charge, and this carbon having a positive charge is known as what? Carbocation. This is known as what? Carbocation. Is everyone okay with this? Now, carbon having the negative charge is known as what? Carbanion. Is it okay with everyone? Any doubt till here? So what is this carbocation and what is this carbanion? Is it okay? And what is this free radical? Any doubt to anyone? If there is any doubt, then please do let me know. No? Now I'm going to ask Netara. Please turn on your mic. First of all, tell me about your area, that how you are and how is your family there? There is any problem?
No, sir. There was no current for the few days. That's it. No problem in our area.
And what about the waterlogging condition?
In our area, it's fine, sir. But
some parts of the Chennai, we are suffering from the waterlogging condition, right?
Yeah.
Now, everything is good?
Yes, sir.
You, your family, your loved ones, everyone?
Yeah.
Okay, fine. So my question is this: if carbon is having carbon is having more electronegativity than the adjacent atom, right? Than the adjacent element. So in that case, what will happen? Carbanion will be generated or carbocation will be generated?
Sir, can you repeat the question?
My question is this. This is for everyone. Please try to listen from here. If carbon is having more electronegative than its adjacent element, right? In that case, what will happen? Carbon will be having carbon will generate the carbanion or carbocation will be generated there?
Carbanion.
Carbanion. Got it? Because carbon is more electronegative, so it will pull the electron from the adjacent element. So if it is pulling the electron from the adjacent element, it means there will be a generation of carbanion because it is pulling the electron. If it is donating the electron, then it will be a carbocation will be there. Is it okay? And it is called as carbanion also, right? Carbocation and carbanion. Fine, guys. So I hope everyone is understanding the concepts. Good. So we have seen about the homolytic cleavage and heterolytic cleavage. Guys, this is the organic part, and this is, from where the problem starts, right? So try to understand. Wherever there will be this type of symbol is coming, it means that what? That it is a, fisherman goes to, when they are catching the fish, they are having this kind of hooks to catch the fishes, right? So if single type of this is known as what? One electron is transferring one side only, right? Let's suppose in the case of what? Chlorine and chlorine. So one electron is going to this side, right? So there will be a single arrow will be this side, right? Single arrow we can draw like this, right? If one electron is coming this side, so single arrow we can put like this. So double arrow will be coming when both the electron is going from here to any side, right? So this double arrow headed will be where there will be both the electron are transferred from one side to another side. Is it okay? Let's suppose double bond is there. and if I'm transferring the electron to this carbon, let's suppose, right? So, and both the electron, because one bond is formed by two electrons. So I will be doing like this, right? And here there will be what? Minus charge will be developed because this bond has been broken down and both the electrons has been shifted to this carbon. So there will be a generation of minus charge over this. Is it okay? So single, this will be donating what? There will be a free radical will be there. Is it okay? No. So homolytic and heterolytic cleavage we have seen. Is it okay, everyone? Any doubt to anyone? Fine. Just a minute, guys. Okay. Now we will be going to see about what? Heterolytic cleavage we have seen. Now we are going to look about what? The reaction intermediates, right? As we have seen just now, the free radical, the carbocation and the carbanion, right? Now we are going to see about their stability, right? Let's suppose we are having what? This carbon and there is what? Free radical is there, right? So CH3, and what has happened here? There is what? The free radical has been generated. First of all, we will be looking about a carbocation. Let's suppose we are having carbon with positive charge, right? And this is attached with one carbon, right? So there is what? 3 bond is with this carbon and there is what? Positive charge is there. Getting my point? So this is one case. Another case is what? Carbon. Here this is what? I am representing this CH3 as what? R. That is what? Alkyl group, right? So this is what? 2 degree carbon. Can we say this is 2 degree carbocation? And can we say this is 3 degree carbocation? 3 degree carbocation. This is 1 degree carbocation. This is 2 degree carbocation. And this is what? 3 degree carbocation. Can we say like this or not? Guys, please tell me. If a carbon is surrounded by 3 carbon, so it is what? 3 degree. If a carbon is surrounded by 2 carbon, then 2 degree. If a carbon is surrounded by 1 carbon, it is what? 1 degree carbocation. Plus charge means what? Carbocation is there, right? Now, try to understand here. This is what? Carbocation. There is a deficient of electron is there with this carbon, right? This group R is what? Electron releasing group. They will be donating their electron. So in this case, this R, and this R, all 3 R will be trying to donate the electron to this carbon. So in this case, as carbon is what? Electron deficient, so it will take electron from these R and it will be more stable in this case, and that's why we are saying that 3 degree carbocation is more stable. Is it okay? In this case, this carbocation is taking electron from two other methyl group, then this is 2 degree carbocation. It is less stable than this carbocation. Is it okay? This R will be donating their electron. This R will be donating their electron. So this is less stable than this carbon. But it is more stable than this carbon, because it is one side, it is donated by a carbon. That's why it is more, in this case, it is less stable. And one case is more, that is what, if there is, let's suppose CH3 and carbocation is there. So least stable will be this. Is it okay? So CH3 plus, then what? 1 degree carbocation, then what? 2 degree carbocation, then what? 3 degree carbocation. This will be the what? The stability order of the carbocation. If you have to write, then please have a note of all these things in your notebook. The stability order of the carbocation. Is it okay, everyone? Any doubt till here? No? Then have a break of 5 to 7 minutes, then we'll be back. Are you there, everyone? Please turn on your camera. So we have seen what about the carbocation, right? Now, the same case, if I will be asking about the carb anion, then what will happen? What will happen in case of carb anion and free radical? Wait for a second, I am just telling you what will be in case of carbocation and carb anion and free radical. See guys, we have seen in the case of carb anion also. Let's suppose there is what carb anion is there, right? So what will happen in this case? And here is what R, and there is what carb anion is there. Again R is there, and again what is there? So this is what 1 degree. Here there is what H is there, right? So if I will be going to ask you about that carb anion, so what will be in this case? Can anyone tell me? Please try to predict that carb anion 1 degree, 2 degree, 3 degree, which will be more stable? Which will be more stable in case of carb anion, carb cation, and carb, and that is what primary, secondary, tertiary. What do you guess, guys? See this case. This is what we are having. This is what methyl, simply methyl. So there is minus charges there, right? This is what methyl, minus charges there. This is 1 degree carb anion. R is there, and H and minus charges there, right? This is 2 degree, and what is there? Minus charge is there. This is what 3 degree, and carb anion is there, right? Now guys, see, R is what? The tendency of R is what? To donate the electron, right? This CH3 group or R alkyl group is of having the giving the electrons, right? So here what will be happening? In the carbocation also we have seen that this R is donating the electron. So here in this case, carbon will be donated by 3 electrons. Already the carbon is having the electrons, and if you will be giving the other electrons, so there will be what? Repulsion will be between the electron and electron, right? So there will be less stable will be this compound. Getting my point? 3 degree carb anion is less, or you can say least stable. Then first of all, this carbocation, that is what? CH3 minus, then this 1 degree carb anion, then 2 degree carb anion, then 3 degree carb anion will be stable. So the stability order will be reversed in this case. Is it okay, everyone? Any doubt? No doubt? Okay, fine. Now I am taking another example for what? Free radical. What do you think about the free radical? What will be happening in case of free radical? If free radical will be generated, then in that case, what will be happening? See guys, in case of free radical, what will be happening? Stability order will be what? See, in free radical also, there will be a need of electron to the carbon. If there will be a need of electron to the carbon will be there, then what will happen in that case? See here. See, this carbon will be needing an electron, but there is no anyone to give the electron to this carbon, right? Because H is not giving the electron, right? But this R, this is what CH3 group is there, so it will be donating the electron to this carbon, right? Again, it will be in need of electron, so this two group will be electron donating group, right? Electron donating group. So the same order of the carbocation will be followed here. So CH3, then 1 degree, then 2 degree, then 3 degree. You have to follow this order and you have to learn these things, guys. Is it okay with everyone? Any doubt? So three things we have seen. First of all, what? Free radical. Second is what? Carbocation. Third is what? Carbanion. If I will be summarizing all these three, then can anyone tell me that what will be the order of the stability for this free radical, carbocation and carbanion? Write in the chat section, guys. Stability order of free radical, carbocation and carbanion. No one has written anything, guys. Please write the stability order of the free radical. What will be this? CH3, 1 degree, then 2 degree, then 3 degree. What will be in the case of carbocation? The same will repeat. 1 degree, 2 degree, then 3 degree. In case of carbanion, what will be there? CH3. Here there will be what? Free carbocation plus will be there. Here there will be what? And here there will be minus sign will be there. Then 1 degree, then 2 degree, then 3 degree. This will be the case that you have to learn. Is it okay? Now we are going to look about what the effects. There are some effects that we have to learn that are what? That are plus I, minus I, that is resonance effect that we have to see, hyperconjugation that we have to see. So there are some effects that we are going to see, right? So first of all, we have to see about what? The inductive effect and electron displacement in covalent bond. So how the electron displacements are there? So first of all that we are going to see is what? Inductive effect. So inductive effect, guys. What is this inductive effect that we are going to see? First of all, this is what? Permanent effect. Permanent effect. Inductive effect is what? Permanent effect. So how this inductive effect occurs, that we are going to see. How this will be happening and what is happening in this case, that we are going to see. Guys, try to understand here. There are two types of inductive effect are there. One is plus I and second one is what minus I. So plus I effect and minus I effect are there, right? See, let's suppose we are having what? Carbon, 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 and Cl group is there. We all are knowing that Cl is what? Electron withdrawing group. It will pull out the electron from the carbon. So there will be a development of positive charge, partial positive charge on this carbon and partial negative charge on this carbon, right? So there will be some charge will be developed on this carbon. There will be some charge will be developed on this carbon. There will be some charge developed on this carbon. Why? We are knowing that if this is electron deficient molecule, then this carbon will be giving the electrons from this side, right? Is it okay? These three carbon will be donating the electron to this carbon to make this carbon stable, right? Is it okay? So this is what? Electron withdrawing group. If this is electron withdrawing group, so it will pull out the electron from the adjacent carbon. Is it okay? Any doubt? So if there will be electron withdrawing group will be there, then it will be minus I effect will be there. Is it okay, everyone? If electron withdrawing group will be there in the last of the chain, so it will be trying to withdraw the electron. So that will be known as what? Electron withdrawing group, or it is known as what? Minus I effect will be there. Is it okay? Any doubt to anyone? So now your question will be what? What are the electron withdrawing groups, sir? Right? So I'm going to make you write that what are the electron withdrawing group is there. NO2, NO2, then Cn minus, then what are the electron withdrawing group are there? COOH, COOR will be there, COOH will be there, then COOR will be there, then fluorine will be there, chlorine will be there, bromine will be there, iodine will be there. These are what? Electron withdrawing group. Apart from this iodine, OH will be there, OH will be there, and phenyl will be there. That is what? Benzene will be also there. So OCS3 and C6H5 will be there. OCS3, then C6H5, then H will be there. So these are what? Electron withdrawing group. If any of these will be with any carbon chain, so it means that they are pulling the electron. If there will be pulling of electron will be there, then it will be what? That will be a minus I effect will be there. Is it okay? Let's suppose we are having carbon of 3 chain and there is what? Let's suppose there is what? COOR will be there, right? So what will be there? It will try to pull out the electron. If let's suppose propane is there and what is there? OH is there. So this OH will be trying to pull out the electron from this carbon. Is it okay? So this is what? Minus I effect. So now what is the plus I effect then? What is this plus I effect? Plus I effect. This is plus means what? Plus inductive effect, right? So if there will be electron donating group will be there. If there will be electron donating group will be there. Electron donating group will be there. Then there will be plus I effect. So what are the order for this? CH3C. If there will be 3-degree carbon will be there, right? CH3C will be there. So it will be what? Plus I effect will be there. Getting my point, everyone? And then CH3C will be there, then it will plus I effect will be there. Then CH2. Sorry, CH3 2 will be there and CH will be there. Then it will be what? less than that. If CH3 and CH2 will be there, then it will be then less. Then again what? If what will be there? If CH will be there, CH3 will be there, so it will be least. Is it okay, everyone? If CH3 will be there, then this will be the least one. So this is about the plus I effect. These are what? Electron donating group. Others were before that we have learned what? Electron withdrawing group. Any doubt to anyone? So plus I and minus I, we have seen about this. Any doubt to anyone? No? Now guys, we are looking about that. What will happen if this happens, right? Plus I effect, minus I effect. What is the need of that? Let's suppose we are having what? Carbon. And there is what? Cl is there, right? And it is attached with what? It is attached with 3 other hydrogen, right? It is attached with what? 3 hydrogen. So it means what? There will be a partial positive charge will be developed here and partial negative charge will be here, because chlorine is what? Electron withdrawing group, and here, so electron withdrawing group is there, so it means minus charge will be there and plus charge will be here. Now, if anywhere alcohol is there, right? Let's suppose we are having alcohol at any position. So what will be happening in that case? Alcohol will be there, right? OH minus. So this is what? Electron rich species, that we can say. That is what? Electron rich species. It means what? They are electron withdrawing group, or you can say electron rich species. These are what? Electron rich species. And you can say when nucleophile. These are what? Nucleophile. So nucleophile are what? They will be in search of a position where there is a positive charge is there, right? So it will attack to this carbon, because this is in need of electron, right? And this is what? Electron donor group. So this will be donating the electron to this carbon, and Cl will be saying this carbon tata bye bye. Getting my point? So what will be happening here? So the new compound will be formed, COH, CH3OH, and plus Cl minus will be there. Is it okay? So how this happens? Is it okay with you? No. See here. So we have completely seen the plus I effect and minus I effect. The other 2 effects are there that we'll be discussing, right? Just a minute. First, do one thing, guys. Start doing your class assessment. Then we will be looking about the, rest part.